In this problem, we need to determine the equation of a parabola with focus at the origin, and the vertex is at the intersection of the lines x minus y equals to 3 and x plus y equals to 1. Let us begin. First, what we'll do, we'll try to understand the problem graphically. So here let's consider two lines with the equation x minus y equals to 3 and x plus y equals to 1 intersecting at a point. So here we have the two lines x minus y equals to 3 and x plus y equals to 1 intersecting at a point, and this point of intersection is the vertex of the parabola. So let's consider it to be V. Now we're going to draw a line which passes through the vertex, and on this line let's consider another point and let this be the focus of the parabola. So let's consider it to be 0, 0. By definition, this is the axis of symmetry of the parabola, because a line on which the vertex and the focus of the parabola lies is automatically referred to as the axis of the parabola. Now, to find out the equation of the parabola, what we'll do, we'll consider a third point on this line, on the axis of symmetry line. Let's call this at point A, and we're going to pass another line passing through this point A, and it's going to be perpendicular to the axis of symmetry line. Now, this line is chosen in a very specific way, such that its distance of point A from the vertex, this particular distance, is exactly the same as the distance of the focus from the same vertex. Then this line will be referred to as the directrix line. Now, our goal will be to obtain the equation of the parabola. To find out the equation of the parabola, we need two information. One is the coordinates of the focus, and the other is the equation of the directrix. Since we already have the coordinates of the focus, our goal will be to obtain the equation of the directrix. Let us begin. Now what we'll do first, let's try to find out the coordinates of point V. That means coordinates of the vertex of the parabola. This is simply obtained by solving the two equations of the straight line. So because their common point of intersection is going to give us the coordinates of V. So here we have x minus y equals to 3. So this is one equation of the line, and then we have x plus y equals to positive 1. Let this be the other equation of the line. Now we're going to add equation 1 with equation number 2. So we get 2 times x, so negative 1 y and positive y cancels out. This will be equals to 4. So this gives us the value of x as 2. Now we can use either equation 1 or equation 2 to obtain the value of x. Let's use equation number 2. So from equation number 2, y will be equals to 1 minus x. Since x came out to be 2, so y will be equals to negative 1. Now that means the coordinates of the vertex of the parabola will be at 2, negative 1. Now that we have the coordinates of the vertex, we'll try to find out the slope of the axis line, or the axis of symmetry. So slope of the axis of symmetry, we're going to denote it by the letter m. So let's call it m1. So all we have to do is take the ratio. In the numerator, we'll take the difference of the y coordinate. So we'll do the focus minus the vertex. So that means we take the y coordinate of the focus, from it subtract the y coordinate of the vertex, divided by the difference of the x coordinate. So here we'll start with the x coordinate of the focus, and from it subtract the x coordinate of the vertex. So this is going to give us negative 1 over 2. So here we have the slope of the axis of symmetry, and if we suppose that the slope of the directrix be, let the slope of the directrix be denoted by m2, then from the definition of straight lines, we can say that the product of m1 and m2 must be equals to negative 1. Which means that the value of m2 will be the negative reciprocal of m1, which is going to give us m2 equals to 2. That means the slope of the directrix line is going to be 2. Okay, now that we have the slope of the directrix line, next what we'll do, we'll try to find out the coordinates of point A. So let's call it A, B. Now here, vertex V is the midpoint of the line segment joining the points A and F. So here we can use the midpoint formula. So since V is the midpoint of AF, so we can say that 2, negative 1, which is the coordinates of the vertex, that can be also obtained by summing up the x coordinates of A and F divided by 2, and for the y coordinate we sum up the y coordinates of A and F and divided by 2. Now that's going to give us A equals to positive 4 and b will be equals to negative 2, meaning the coordinates of point A is going to be 4 comma negative 2. Now we have the directrix line passing through the point A with coordinates a comma b and having a slope of 2. What we can do, we can use the point slope form of a line to obtain the equation of the directrix line. So let's quickly go through the point slope form. Let's say we have a straight line which passes through a point having the coordinates x1 comma y1 and the slope of that line is m. Then the equation of that line will be given by y minus y1 equals to the slope times x minus x1. So this is the point slope form of a line. Okay, so let's try to find out the equation of the directrix using the point slope form. So the equation of the directrix is going to be y minus y1. y1 will be negative 2 equals to the slope multiplied to x minus x1. X1 will be 4. So we get y plus 2 equals to 2x minus 8, which are rewriting the terms, we get 2x minus y minus 10 equals to 0. So this is going to be the equation of the directrix. And now we have the equation of the directrix. We already have the coordinates of the focus. We are ready to obtain the equation of the parabola. So let us begin. So here we have the equation of the directrix. 2x minus y minus 10 equals to 0. We have the coordinates of the focus. At 0 comma 0, we'll consider a point P having the coordinates x comma y, and the point P is referred to as the locus of the parabola, with the condition that if we join point P and point F and you drop a perpendicular from the same point P on the directrix line meeting it at M, then by definition of a parabola, the two distances, that means PF, must be equals to PM. Now let's try to find out the length PF using the distance formula. All we have to do is take the square root, and then the square root will take the difference of the x coordinate, square it, and then add it with the difference of the y coordinate whole square. This will be equals to the perpendicular distance PM. Now there is a formula for finding out the perpendicular distance of any point from the directrix lines. Let's go through the formula. So let's say we have a point P with the coordinates x1 comma y1. And then we have a straight line with the equation ax plus by plus c equals to 0. Then the perpendicular distance of point P from the M, that's PM, will be given by the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. So here a and b are the coefficients of x and y, and c is the constant term of the straight line. We're going to use the same formula here. We'll have to take the absolute value. Inside the absolute value, we'll consider a ratio. We'll start with the numerator part. So here we'll take the coefficient of x, that's 2, which gets multiplied to the x coordinate of p. This will get added to the coefficient of y, which is negative 1, which will get multiplied to the y coordinate of point P. And then we have the constant term, that's negative 10, divided by the square root of, we have to take the sum of the squares of the coefficient of a and b, so that's 2 squared plus negative 1 squared. Right. So let's further simplify. We're going to get the square root of x squared plus y squared equals to the absolute value of 2x minus y minus 10 divided by square root of 5. We're going to square both sides. Squaring gives us x squared plus y squared equals to 2x minus y minus 10 whole squared divided by square root of 5 whole square. What we're going to do, we'll cross multiply with the expression on the left hand side. That's going to give us 5x squared plus 5y squared will be equals to, we're going to expand 2x minus y minus 10 whole square to get 4x squared plus y squared plus 100. And we have negative 4xy plus 20y minus 40x. So let's combine the terms. So we have 5x squared minus 4x squared gives us a positive x squared. 5y squared plus minus y squared will be positive 4y squared. Then we have positive 4xy plus 40x minus 20y, and then we have negative 100 equals to 0. And this is going to be the required equation of the parabola.